All right, in section 5, we're going to be finding the volumes for prisms and cylinders and pyramids and cones. And so this first video just focuses on the beginning part, just focuses on prisms and cylinders. And the formula for volume for both the prisms and cylinders, and again for pyramids and cones, are going to be virtually identical, all right? And so there's going to be 2 formulas total that we're going to work with. This first video just focuses on the first one, which is the volume of one of these figures is found by taking the area of the base and multiplying it by the height. You're essentially taking those square units and multiplying them through the whole depth, through the whole height of the three-dimensional object. So here we go. We are starting with a triangular prism, and here we know of, on this triangle, I've got 10 meters, I've got 6 meters, and I've got then this distance between the 2 triangular faces as 5 meters. Now the one thing that we had to struggle with and really wrestle with in section 3 is identifying the bases of our prisms. It's typically not a difficult task to find the bases of a cylinder, the bases of your pyramids, the bases of your cones, but when you're dealing with prisms, we kind of have this default to think that base means bottom, and this rectangle on the bottom is not the base. All right, it is not the base. The bases in a prism are defined as the congruent parallel faces. So the triangles, the triangle that is 10 meters tall and 6 meters long, is the base of this prism. All right, and so I want you to think on that. I want you to be okay with that. But essentially, what we're going to do is to find the volume. We're going to find the area of the base and multiply it by the height. Again, identifying the bases as the 6 meter by 10 meter triangle means that the height is the perpendicular distance between those parallel faces, and therefore the height is actually 5 meters. All right? That might be a struggle for you to grasp, and that's okay because you're just learning this. I invite you to, again, check out your textbook, follow the examples there, or again, consult with me if you have questions. The area of our triangular base, of course, this is where Unit 7 comes in handy, because we need to know how to find the areas of these bases. The area of our triangular base is going to be 1/2 of the base of the triangle times the height of the triangle. Now that is different than the base of the triangular prism and the height of the triangular prism. So you see why the letters that we use matter, all right? And our abbreviations and our understanding of the formulas really have to matter here. The height of this figure is 5 meters, all right? Again, sorry for the handwriting. You guys know the drill. And so here we have 1/2 of 60, which is 30, and then 30 times 5 is 150. These meters are cubed. This is in cubic meters because we are multiplying 10 meters by 6 meters by 5 meters, and so we end up cubing the amount of meters in the item. All right, and so that is 150 cubic meters. On the cylinder question, we're going to use the same exact formula, but the formula for the area of the base is different than the formula for the area of a triangular base. So obviously we're going to have to be flexible as we've jumped from one type of figure to the next. If we're dealing with a rectangular prism, then we're going to have a rectangular base. If we're dealing with a hexagonal prism, then we're going to have a hexagonal base, and we'll need to use the appropriate formulas. Here, when we're finding that the volume is equal to the area of the base times the height of the figure, we understand that the circles are the bases of our cylinder, and then the perpendicular distance between those circles is the height. So the height is actually 8, and the bases are the circles. So the area of the base is going to be pi times the radius squared. The height, we know, was 8. So our volume is going to be 9 pi times 8, which is 72 pi, and these centimeters are not squared. These centimeters are cubed. Those are cubic centimeters. So 72 pi cubic centimeters, answering again in terms of pi, and 150 cubic meters will be our volume.